Thanks, Craig, for the introduction. This is my first nanog, and I can already say that it's been much more rewarding than any of the conferences I've attended. 3 t-shirts, 2 ball pens, 1 optical mouse, and 1 laptop light. I can go back proud of myself. So thanks a lot for inviting me here to talk about my tool. Today I'm going to talk about LinkRank, which is a tool we have been developing over the past few months, actually a year and a half, 2 years. This work started in 2002, summer of 2002, and involves Dan Massey, who's also here, as well as Lixia, who's also present in the audience. We also have another student, Tim Ma from UCLA, who's working on this. So one motivation why this whole work towards LinkRank started stemmed from our own difficulty to understand tons and tons of BGP updates that we had accumulated. And what we really needed at that time was some tool that could just summarize these huge chunks of BGP data and tell us what exactly happened. So with this, we started designing this tool called LinkRank. And at the same time, we also wanted this tool to be useful to operators and, in general, people from ISPs. So let's move on to what kind of questions can be answered by a good BGP visualization tool. So the foremost question that can be answered by a good visualization tool is which AS links are important to you. Now, most of us know who our direct peers are, and so it's not so much of a problem understanding the peering with our direct neighbors. But beyond our direct neighbors, what the picture is not very easy to understand. So this is one of the questions that can be answered by a good visualization tool. Beyond just visualizing your routes, you're also interested in routing dynamics. In particular, you want to know on any given day what kind of routing events are happening. Are they affecting your routes or not? You also want to know whether you are being affected by routing instability that is more than 1 hop away, which you cannot do much about. And finally, for the effects that you do observe, you want to know whether it's global or it's local, which in case it's local, you can just talk to your neighbors and sort it out and so on. So these are some of the questions that a good BGP visualization tool can answer. So in this slide, I'm going to introduce very briefly what I mean by BGP visualization. So it's very clear and we can dig into the tool in detail. So the graph on the right-hand side is an AS level graph. It's a very simple graph. You have each node as an AS and you have 2 prefixes being advertised, P1 and P2. Okay. And this is how the route looks like at a given instant of time. Now what you have is an update coming from your blue neighbor, which withdraws the path to prefix P1. As a result, your new path goes via AS3 and AS5. Okay? So you have another update coming in from your red neighbor, which now withdraws the path to P1. So your new path, there is no new path. And finally, you have a third update coming from the same neighbor, which changes the path for P2. And so a new path now becomes AS3, 6, and 7. So this is the kind of visualization that I'm looking at here. The only difference is that it's at a much larger scale. When we are talking about 3 updates, it's very easy to just draw it out and lay it out. But in reality, visualization presents many, many challenges. And to look at what kind of challenges we are facing, we list them in 3 dimensions. The first is topological granularity. Clearly, you have so many AS links, you have so many prefixes, it's not easy to decide on which prefixes or which AS links you want to visualize. So that's the number 1 challenge you face. The second challenge is the time dimension. You have updates arriving on a continuous basis, you have clusters of updates, you have periods of low activity. So you want to be able to decide on what's the best time to, or what times are interesting to observe routing dynamics over time. And finally, you have more than 1 views, like route views, for instance, archives data, and it has lots and lots of viewpoints. And you want to be able to combine views to get a better picture of routing. Besides that, a sub-challenge in this is also to identify which ones are the right ones to combine together. So these are some of the challenges we face in visualization in general. And as a first step, As a first step, what I'm going to do is just take the simplest possible case in each of these challenges, and then we'll move on and make it more complicated. So for topological granularity, you can start by viewing all possible links. For time, don't worry about the whole time dimension, just focus on a particular instant of time. Similarly for view, just pick one particular view. And let's look at this toy graph that we present. This toy graph is so that people understand the notion of link rank and rank change that we use to the talk. And once we move through some examples with this toy graph, we'll dig into some real examples so people can understand what we do here. So in this toy graph, we assume that each AS, which is a node here, hosts about 100 prefixes. So link rank, which is defined as the weight on these graphs, on these links, is essentially the number of prefixes that you can reach by using that link. For instance, if you look at link 4.5, the link rank is 100, which means you can reach 100 prefixes using link 4.5, which is not surprising since since AS5 is hosting 100 prefixes. In contrast, link 1.2 can reach about 500 prefixes because it has neighbors that it connects to. So clearly, in a real case, link rank graph is going to be too big, too messy, and you want to abstract out details that make the graph viewable. And so what we do as a first step is you can apply a threshold to see only links above a certain usage. So in this case, for example, if you apply a threshold of 200, what you see is this much smaller graph. So having found a smaller graph, we still face a challenge of what happens when we deal with updates. So that on the top here, you're receiving updates on a continuous basis, and assume you have 100 updates which change path for 100 prefixes hosted by AS4. So when you receive each of these updates, the link rank state is changing because each update is changing the path one by one. Now the challenge is, when do you decide that you've had enough and you want to visualize these changes? So it's not easy to know when to take a snapshot of the system to visualize. And one way to deal with this, or this is our way to deal with this, is to take a snapshot when the running total of links that change, the rank change, exceeds some user-defined threshold. So in this case, if I'm interested in events that change links with weights more than 100, I can see that I have the starting point and the ending point where finally I've seen that 2.7 has changed more than 100 or 2.4 has lost more than 100. So these define my starting and ending points. And once I have my starting and ending points, I have something to visualize. But even in this graph, if you see, you have link 1.2, which is common to both the graphs with the same weight. So if you want to summarize the change and not just the static route view, we define the notion of a rank change graph. Now, rank change graph is very important to understand how BGP dynamics are. This graph captures just the difference between the two snapshots you have taken, and it eliminates links with the same weight or weight below the threshold. So a rank change graph in this case would look like this with two kinds of links, the red links which indicate loss and the green links which indicate gain. The weights on the links is the amount of change that has occurred. So summarizing, rank change graphs show which links have changed in a given time interval, and red indicates loss, green indicates gain. Even with this, you still haven't understood how to view events on a time dimension. So what you really want is some kind of a high-level plot that tells you interesting events occur at this particular instant of time. We tried playing with update plots, and we realized that updates do not necessarily reflect the amount of routing dynamics going on. So we decided we need a helper plot, which we call as the activity plot. What the activity plot does is gives you a high-level picture of where the interesting routing dynamics lie. Now you see there are some chunks of red and green bars out here. I'll explain in a minute what they stand for, but the starting point is that wherever there's a high density of red and green bars, there's a lot of activity going on. So what do these red and green bars mean? Looking at the same example that we've carried through, what we do at any given instant of time is just sum up all the losses and plot a red bar, and sum up all the gains and plot a green bar. So you have this done at various points, and you can see periods of inactivity in which the routes have not really changed much. So there are various implications this activity plot could have. The first one is you could have the green much higher magnitude than the red. And this could be due to a combination of just longer new paths, like in this case, for instance, it's a longer new path, or it could also be due to gain in the number of routes. It just happens that there are new routes being announced, and so you have new green things coming up. A mirror image of this case is the second case in which the loss is much higher than the gain. So the interesting implication is the third one, where you have a bunch of red bars. Now this is interesting because this is suggesting that routes are being lost, but they are not being gained. So this is always an interesting thing to look at, and in general, sometimes or most of the times indicates loss of connectivity. So activity plots give you a good feel of what is going on in the network, and this can be a starting point to look at details on the network. However, it's not just limited to a view along the time dimension. Often you can identify common behavior across different peers or different views by looking at the activity plot. In this case, this is from real data. We've plotted activities from various points, and I couldn't scroll down, but there are many other points which have similar behavior. You can see towards the end of the plot, there's a lot of activity, a lot of views show similar activity, which is 2 bars. And this can help you not only understand that there is a global routing dynamics going on, but also to identify common views which share a common behavior. Okay. So now with this, we are ready to dig into some real case studies and look at the LinkRank tool, see how it can help us. The first case study, we observed from our activity plot there was some high amount of activity going on one of the ASs or one of the viewpoints that we have. This data is from route views. There is a timeline at the bottom right which shows when this data is from. The blue node indicates the point of observation. As defined before, red stands for loss, green stands for gain. The weight on the link, -1417, is the loss and the corresponding gain, and so forth. The activity graph shows down here there's a lot of activity going on, and we would like to see what exactly this hundreds and thousands of updates have done. So we have some controls here which can move you through the activity graph. I'm going to step one at a time. We see now between these two, there was a loss, and then right after that, there was a gain within 5 or 6 minutes. Then there was a loss again, a gain again, loss, gain. This kept repeating alternately, and then finally things settled around here. But did they? Because when we move it out to this section, you can see that the similar kind of loss gain compensation still carries out. And it's not over even here. Even here, it's the same story, but it's just more spaced out now. So this kind of visualization gives you a good feel of what is happening in these hundreds of thousands of updates that you observe at these monitoring points. Okay. That's one way of using LinkRank, is you just have one monitoring point and you see what is happening from that monitoring point. The second case study focuses on how you can use LinkRank to make some kind of inference. Now the tool does not do inference on its own, but you can use this tool and some common sense to do some kind of inference. What I call this is inference by choosing relevant views, and it will be clear in a couple of minutes what I mean by relevant. This is a graph that we observed from 3130. Again, the timeline is July sometime, which is pretty recent. The blue node is the point of observation. Notice there are 2 nodes with the color orange. And these nodes are nodes that have views in your data. So these are points you can actually view changes from or view routes from. And that's interesting because now you see that there is a loss along the path through 2914, and there is a gain along the path through 1239. And you want to know what has caused this route change, or these 250 odd prefixes to move from the red path to the green path. So how do you do that? You are lucky enough in this case to have 2 observation points on your lost as well as gained path. So you can look at 2914 to see whether 2914 is seeing any changes. If it is seeing any changes, then most likely the problem lies beyond 2914 and so forth. So looking at 2914 in the same interval, we see that it has changes, but it does not have changes towards 1299. It has changes towards an AS6395, which is an unrelated, possibly unrelated event. So what's the other cause of this route change? Things look to be okay on 2914. Maybe it's some problem beyond 1299, but if it was, then again 2914 would have had a change. So you move on to the green path and see what happens from 1239. Did 1239's route to 8437 change in any way? And when we look at 1239, you see that 1239 in this time interval had a longer route to 8437, and all of these prefixes now move to a direct link between 1239 and 8437. The value in the brackets is the rank change here, and the value outside the brackets is the link rank. So you can see the green bar saying 559 plus 559, which indicates that before this event, the link rank of this link was 0. And it's just because of this event that it's moved out. So with this kind of diagnosis, with possibly multiple views from different points of observations, different ASs in particular, you can understand these routing changes much better. Okay, so next we look at how LinkRank fits in with some other existing tools. Another tool that most people might know of, some might not, that was being developed parallelly and independently from LinkRank is BGPlay. BGPlay currently is available from route views, and the focus of BGPlay is to show routing dynamics as observed at a single prefix. And we feel that this is very complementary to what LinkRank does and can be used in a very good way to understand the routing dynamics much better than each of these would individually show. So you could either start from LinkRank, and then when you see something interesting, move on to specific prefixes that you want to analyze. Or you could start from BGPlay and move on to LinkRank to find out what is the broader picture of what BGPlay shows you. The best way to explain what I mean is with an example. And for this, I'm using the third case study, which, interestingly, is from yesterday. The reason I put this case out is because it's still fresh, and some of you might have read it on the Nanog mailing list. There were a few mail exchanges on the Nanog saying some problems with a major ISP. It's been masked here, but most of you would probably know what it is. So this is the viewpoint 3130. Remember, note here that 3130 is not connected to 1239 simply because there are no rank changes between 3130 and 1239. So all the rank changes are occurring from 1239. Now you see that there is a red path out here somewhere, and there is a green path which is compensating the rank losses. So this coincides with the time that the event was supposed to have happened. And what we do is to understand this better. Again, when we see link XY, we see that the link rank has moved to 11, which is almost close to 0, which means the link is almost completely down. So what we do is we look at some prefix from ASY to understand why prefix from ASY is changing. And for this, we use BGPlay. Now you can see that, okay, so this graph is, so I had to mask the AS names, and so I've made it ugly. I've driven them to corners where you cannot see. But let me explain with the help of this mouse pointer. This was the original path, and now the paths are moving to this alternate path. The AS names are not visible out here, but clearly it's not just one observation point that is seeing this prefix moving around, but it's multiple observation points. So for this particular prefix, I see that multiple observation points are having route changes, and this makes it interesting. So the next thing I do is I use the activity plot. And I plot activity from various peers that I have access to, and I see that during this time, this is the time of the event, I see a vertical bar, which is a high magnitude bar, indicating something happened. How many peers did it happen at? Let's look at. So when we scroll down on the activity bar, it seems to be consistent on almost all the peers we observe at, besides some other dynamics which are also present which vary. But this bar seems to be consistently seen across a lot of peers, a lot of views, which is what I mean. And when you see so many views seeing something consistent, you want to be able to combine all these views into one global picture which you can understand much better. This is something that LinkRank does quite well, and we are still working on some interface issues, so I cannot show you how the thing would actually look, but we'll figure that out pretty soon. I can show you a hand-constructed graph which is taking into account some visualization issues, which looks like this. For simplicity, I have included only five views in this case. The dashed lines in this case indicate loss, the solid lines indicate gain. And the color of the lines corresponds to the color of the observation point. So, for example, the red line is 3561 and the orange line is 3130, which is not directly connected to 1239 from where the changes take place. So such a picture not only tells you what is wrong in the network or what is going on, but also sort of tells you where the alternative traffic is moving. You can see that almost all of this has moved to the peering between Z and Y. And this is an indication of how the routes get balanced when events like this happen. Another tool that is pretty popular is Route Explorer. We once again feel that LinkRank complements Route Explorer. I would like to remind the audience that LinkRank was designed with an objective of global monitoring. And we had this aim or objective of being able to combine views from different ASs right from when we started. In this sense, LinkRank complements Route Explorer very well because Route Explorer combines many views from inside an AS. And so we feel we can use these tools together to get a much better picture. Also, LinkRank does not provide any kind of automated inference. It's a helper tool. We rely on operator expertise to make inference. There is, though, some ongoing work going on in our group on graph theoretic fault inference, and we hope that some of this might directly translate into the LinkRank tool. In summary, LinkRank is used to make sense of huge chunks of BGP data, and I have used this tool personally a lot, and I find it very useful to get a good feel of what has happened in a particular day or in a particular week in no time, in absolutely no time. LinkRank can do a very good job of combining views from various observation points, and we feel this is a very useful feature that LinkRank has. It can give you a good idea of what is the common behavior as well as what is a global snapshot of the routing as observed from various points. You have thresholds and a drill down feature which I missed in the demo, but what the drill down feature does is it can zoom into a time interval which has high dynamics to present you with more details. So you can keep zooming on into time intervals until you are satisfied. So if your activity graph spans, let's say, a month in this much, you can zoom into a particular area which would then be 1 week, then zoom in, it would be 1 day, and so on and so forth until you are happy with what you see. And activity graphs, which is very useful in understanding where the dynamics lie. Make sure that you do not miss routing dynamics so easily. So, final slide. This is why we are here, point 1. We are seeking input from the operators, from the NANOC community on how we can improve this tool and how we can tune it to be more beneficial to the general audience. We are planning a beta release sometime in December. There is a plan of doing some preliminary testing before that, and I would be more than happy to hear from people who are interested in being a part of our testing, who would like to use our tool initially. And if you're interested, please do get in touch with me. If you're interested in other clarifications, views, get in touch with me. I'll be, till the end of the day, right outside. I also have more cases if you want to look at the tool in more detail. Since I have not shown all the functionality because of the time constraints, you can catch me or send me an email. And that just about summarizes the talk. So, yeah, questions?
Bob Haskins, Renesas. I was curious how well your tool works with large numbers of routing updates. We're talking like millions of updates.
So we have. So when you talk of large number of routing updates, there are two ways this could occur. This could be either from a single viewpoint, or it could be from multiple viewpoints. Most of the times, we've seen that the larger the number of updates, the easier it is to capture with LinkRank, because LinkRank is designed to capture bulk dynamics. So in that sense, I'll be happy if you have large events with large dynamics, because LinkRank won't miss it. But if they are very small events, then there is a chance that you might miss it with LinkRank. So yes, answering your question, it works better larger the updates.
Any other questions? I think one question.
Sure.
So the LinkRank right now is based on a number of prefixes. Is that something you can change? Not all prefixes, of course, are created equal. Is it configurable to look at ASNs, amount of addressed space?
That's a very good point. I actually missed that point. I was going to say that before. We are looking into alternative metrics for LinkRank, and Craig just mentioned one of them. Address space is one thing we are sort of half done on, and we feel the idea here is that you treat a /24 the same as a /8. You just give it one weight. And some people might find that's not fair, so we are looking at alternative metrics, and that should be available in the release that we come out with in December for sure. So, yes, we are.
Okay, I think that's it. Thanks.
Thank you. Thanks.